Hey guys, sorry I'm out again today. Hopefully I will be back tomorrow. But I did want you guys to carry on with one more activity in and around mole calculations. And in this particular activity, you guys should already have in front of you. Uh, you should have your sheet, your paper that says mole baggies at the top. All right. You're going to need your periodic table as usual, and then of course you'll need a calculator since we are doing mole calculations with this activity. All right. And the basic idea with this activity is you guys are going to use the molar mass, which is semi-unique, somewhat unique for each compound, uh, to help identify some unknown white solids. So each baggie around the classroom at 7 different balances has a different ionic compound. All of them are white, kind of powdery solid. There's some minor differences in appearance, but by and large, you can't really tell exactly which is which just by their appearance. All right. And so you guys are going to use the molar mass that you can calculate from the information by using a balance and the information on the baggies to help identify which compound is which. But first we have to complete this table right here. All right. Now, this table right here is pretty straightforward. You guys have been practicing molar mass calculations for quite some time now, so this is a fairly simple process, right? It's also a review of how to write correct formulas. All right. So all we have to do for this one is go through this table, identify the correct formula for the name listed, and then also use the mass of the elements involved plus their subscripts like we've been doing all along. So for example, let's go barium phosphate. Why not? All right. So barium we know is +2. It's in group 2 on the periodic table. Phosphate, that ATE ending tells you it's a polyatomic ion. And if you go to your polyatomic ion list, you'll see that it is a -3. So our formula is going to be Ba3 parentheses PO42. All right. So what we have to remember, and you've got some space off to the side and so on, but we've got barium with a mass of 137.33, but we have 3 of those. So we go 3 times 137.33 plus, let's see, we got 2 here, so 2 phosphoruses. So we're going to go 2 times 30.97, which is the mass of phosphorus, plus, because we have a 4 inside and 2 outside, we're going to multiply those two, so that's 8 oxygens, so 8 times 16.00. All right, we're going to end up with quite a large molar mass on this one. I'm going to punch those numbers in my calculator. I get a grand total of 601.93 grams per mole. Okay, so this is what you're going to do for each of these on this list. So once you and your table group have finished writing the formula, coming up with the molar mass, right, you can then flip to the back side of your paper, and this is where you guys will be getting out of your seats and rotating around the room. First of all, does not matter. You can go in any order, meaning you don't need to start with baggie A, which would be over at station number 1, right? Working clockwise around the room. They go A, B, C, D, E, F, G. So you can go to any baggie to start with. Does not matter. They are independent of each other. All right, and then we're just going to walk our way through these directions. So the bag's mass on the table below, so that goes here. That should be on the bag already. So that mass has already been written on the bag for you. Okay. For the mass of bag and compound, you're going to use the balance for that one. So you just take the little baggie, put it on the balance. Now on this one, right, make sure bag is not touching the sides of the balance, right? The little baggies are flimsy, and if you just lay them on flat, part of the bag is going to drape over and touch the sides of the balance, that's going to mess up your total mass. Okay, so it's okay to fold that baggie up or whatever. Make sure that the bag is only touching that metal plate on top of the balance. All right. All right. Then to get the mass of the compound, all right, it's just a simple subtraction, right? Take the total mass, subtract the mass of the bag, and got this one. All right. Moles should also be written on the bag. All right. Now the molar mass is where you're going to have to do your major calculation. All right. So the way we'll do that, it says it right here. You can determine the molar mass of each unknown by dividing the compound's mass by the number of moles present. So basically, the reason we're able to do that is you guys have learned that moles times molar mass equals mass, the total mass of the thing, right? So the values you guys are going to know from your measurements, you're going to know the moles, and you're going to know the mass, right? And then our molar mass is our question mark. So we could just basically, if we treated this like x, for example, in algebra, mass times x, or moles times x equals mass, right? We could just divide both sides by moles. Right? So the molar mass equals mass over moles, right? So the moles is written on the baggie for you, right? The mass you will figure out by taking the total mass, subtracting the mass of the bag. Mass over moles will give you your molar mass there, right? Then to determine the compound's identity, you're just going to pick from your list, right, which molar mass from the list most closely matches your molar mass, right? Now, because each balance is going to have some slight variation from the other, you might get slightly different numbers from other table groups, right? That's to be expected. These are high school chemistry class balances. They are not super duper high precision instruments. Okay, so you're going to get a little variation. So your molar mass you get might vary slightly from the actual molar mass you calculated from from this table, from your first table. All right, your job is just to pick one that most closely matches. All right. And if you don't quite finish this today, just turn it in on Friday, which I should be back by then.